So we're going to factor solve and graph this equation, and also find the halfway points of the intercepts to have a better idea of how high and low the function goes. So if we're going to factor this, we'll take out a GCF of 2x first, because 2 and x can divide each of those terms. So that'll leave us with 4x squared minus 9 equals 0. It looks like this now is a difference of squares. So that'll break up into the conjugates 2x plus 3 and 2x minus 3. Okay, so now that we have no more difference of squares, we can solve each factor. So x would be 0. Here we would have to minus 3 and then divide by 2. So negative 3 halves. And here we would add 3 and divide by 2. So positive 3 halves. So those are our three solutions, and they're also all real, so they're all roots as well. So we cross at 0, negative 1.5, and 3.5. All right, so that's the those are the intercepts. Now for the halfway points, instead of going directly halfway, I'm just going to plug in a negative 1 and positive 1, just to have a better idea of how high and low this thing goes. So I'm going to do f of negative 1, f of 1. So f of negative 1 would be 8 negative 1 cubed minus 18 times negative 1. And that gives us a value of 10. So that, again, that's good information. That means negative 1 goes all the way up here. Typically, we don't draw our curves that high and low, but this will give us a more accurate idea of exactly how high and low they go. So negative 1 gave us 10, and then if we plug 1 into the function, we get a negative 10. So 1, negative 10. All right, so the last thing we're going to check is what our end behavior should look like, and then hopefully all 5 of these dots will connect nicely. So for end behavior, we look at our leading term. The degree is 3, so our graph is going to act like a linear function because it's also an odd degree. And since we have a positive leading coefficient, our end behavior is going to be like a positively moving line. So we can use that because on the left side of our graph will be down, and on the right side of the graph will be going up. So I'm now going to start down here, and hopefully all my dots will connect nicely. I'm passing through each intercept because they occurred only once, which means that we'd be crossing through those points. So there's a good sketch of this polynomial function.